Hi, in this lecture we are going to discuss about sets in Python. Already we have discussed about list, tuples and then dictionaries. The next structure which is defined in Python, which is very helpful, is set. To start the significance of sets, let us begin with the problem. The problem is, an university has published the results of the term and examination that was conducted in April month, and the list of failures in 4 subjects, that is physics, mathematics, chemistry and computer science, are available. Separately they have the list of failures for physics, mathematics, chemistry and computer science. Now the problem is, you have to write a program to find the number of failures in the examination. So when I say number of failures in the examination, they might have failed in one or more subject, right? And this includes the count of failures in one or more subjects. So there may be duplication. We cannot just count. For example, if physics is having 47 failures, mathematics is having 51 and chemistry is having 34 and computer science having 12, let us assume like this. We cannot directly add the numbers because the names might be repeating in the list, and we should consider them as a failure of the examination for only once. So this is the task. So this will be easily solved using sets. Before discussing about sets, just look at the PSE of the problem. The input is going to be the register number of the failures in each of the 4 subjects, in maths, physics, chemistry and computer science, and the output is going to be the total number of failures. And the concepts involved in solving the problem are, you have to create a list of register numbers who have failed in one or more subject, and you have to count the number of students in this list. So for example, if you consider that in physics we have these failures, that is S1, let us assume these are the names of the students, S1, S2, S5, S6, and in chemistry you have S3, S5 is repeated here, you can see, S4, S7, and in maths S1 who is already failed in physics is there, S3 who is already failed in chemistry, S5 is also failed in chemistry, S6 is failed in physics, right? So they are failures of maths. Similarly, computer science we have S5 and S7. So when you want to identify the failures of the examination, it's only 7 and there are 7 students as listed out. Yeah. So let us see the pseudocode of this particular problem. What will be the pseudocode is, you have to read the maths failures, physics failures, chemistry failures and CS failures, and this is a new entity. Okay, this failure is a new thing which is initially empty, and for each item in maths failure we are going to add the item to failure. So this failure is going to hold all the list of failures in the examination. Okay, so first we take the maths failure set or list. From that we are going to add the item, because that is the first list. So we can add all the items in the maths failure into the failure list. And then what you are doing is, then you are taking the next one, physics failures. In physics failure, what you are doing is, you are taking the item one by one and you are checking it. If the item is not in failure, okay, failure is the whole list. Okay, I am checking if that item is not in failure, then I am going to add the item to failure. And for next you take the chemistry failure list. If item is not in failure, then you are going to add that. Similarly for CS failure also, you take the student name. Actually here item refers to the student name. You take the student's name one by one and add it to the failure list if it is not already present in the failure list, right? And then you are going to set a count equal to 0 and you are going to count how many elements are totally present in the failure list. That is the desired output of the problem, right? So when you look at the algorithm, we can solve this problem with the list itself. Okay, already we have seen about the list data structures in Python. With that itself we can solve this problem, but when we look at set, you will find it very easy and the number of lines of code will be very less, which will be very comfortable for programmers. Okay, so let us see what is an set. Very important keywords are here. It is an unordered collection. First thing you have to understand is there is no order. So, when I say that there is no order, similarly we have seen another one data structure which is unordered is dictionary. When I say unordered, it means that the elements doesn't have an index. When you look at list or tuple, they are ordered. So, when I want to refer to an element in the list or tuple, I can use index. So, it will start from 0 to n minus 1. If there are totally n elements, it will start from 0 to n minus 1. Here, but when you look at sets, it's an unordered collection. There is no indexing concept at all, right? Unordered collection and then unique. This set is equivalent to the set what we have learned in the higher school, higher secondary school, or in higher in your 6th standard or 7th standard, where you will not have duplicates. Okay. So, here also you will have only unique set of elements, and important thing is you can have only immutable objects. Okay. So, when I say immutable objects, it means that I cannot have object which can be changed. So, when I refer to objects, here I can say it is an integer or float or string, list, tuple, dictionaries, everything are objects, right? When we say immutable, integer, float, strings are immutable, right? And then when you look at list, it is mutable. So, I cannot have a list inside a set, okay? And then tuple, when you look at it, it is immutable. So, I can have a tuple inside a set. And then when you look at dictionary, they are mutable, right? So, I cannot have a dictionary inside a set, okay. So, this is very important. These three keywords you should remember. Set is unordered, going to have only unique elements, and the elements should be immutable, should not be changeable, right? But when you look at the entire structure of set, it is mutable. So, what do you mean by set is mutable? Means I can change the element, I can remove an element, particularly I can remove an element from the set, that is I can change the set, that is possible, but the elements inside cannot be changed, should not be changed, that is the constraint, okay. And already we have seen there should not be any duplicates. And when you look at it, sets are iterable, we will see how, and it can grow and shrink on demand. It can, you can add elements to a set, that's what. When you say that it is mutable, then you can modify it. You can either add elements to it or you can remove elements from it. That's what is said here. It can grow and shrink on demand and can have variety of object types. So, it can be heterogeneous. The elements can be of different type. This is what is about set. And as already we have discussed, it does not support indexing because it is an unordered collection of elements. So, first we will discuss how to create a set. And the first thing in any of the structure that you have to know is how to create an empty structure, right? And we have seen that Python differentiates the structure only by braces. When you look at parentheses, that is used for tuple, and when you look at square brackets, that is used for list, and when we look at curly braces, that is used for already dictionaries. So, we are left with no braces, but when you look at dictionaries, actually each element will be a pair of items, right? It is not going to be individual elements. So, the idea is we can take the curly braces, which is already used for dictionaries, for set, because in dictionary you should have each element as a pair of items, right? But in set, each element is going to be individual item. So, it is possible to have, but only thing that will create the issue is empty, okay. Already we have defined empty curly braces for empty dictionary. So, we cannot use the same empty curly braces for set, then it will become ambiguous. So, how do they indicate empty set is by using this function set and empty parenthesis. So, when I want to initialize a variable by empty set, or when the system wants to say that a set is empty, it will just indicate by set empty parenthesis, right? And this is a set of integers. So, we have put within curly braces set of strings, and you can form a set also, right? So, this is a string, you can use this set, this is type conversion, like what we were doing when we read an input. If you want to convert it to int, we were using like int of input. Similarly, if I have got a string, I can convert it into a set by using this type of conversion function, set of span, right? And then when I print x1, I will see that it will contain the characters in the string. Now we will see the operations in set. The first operation we are going to see is add operation. So what is add operation is you are adding an element into a set. So let us assume that there is a set x1 with 4 characters, what we saw previously. Now when I say x dot add allot, totally there will be 5. Okay, since it is unordered, you can see that it is just going, it may not be the same when you try on your machine. Okay, since it is unordered, the order in which it prints the element will be different each time, even it may change. Similarly for dictionaries also it may change, and when you try on your machine you may get a different result and so on, right? So but there will be totally 5 elements and the new element will be inside the set. Let us assume that there is a set with 4 elements, 1, 2, 3, 4. Now when you look at this, we know already the operations that can be performed with set, what we have learned in school: union, intersection, difference and so on. Those operations can be made here also. Subset, superset, everything is defined in the sets data structure of Python. So when you look at union, how it is defined as, you can use this OR operator. Okay, so let me say S1 is 1, 2, 3, 4 and I am going to form S2. How S2 is formed is, you are taking another one set with 4 elements, 1, 5, 3, 6 and you are going to take a union of this, right? When you take a union of this and you print S2, what will happen is you will have only 6 elements, because when you look at these two sets, 1 and 3 are getting repeated. 1 is present in this S1 also as well as in this S2 also, and we have said that set is a unique collection of elements, so you will not have one to be repeated. Okay, we can check this in the terminal. So can go and put it on the terminal, right? S1 is this, and when you try S2, right? Okay, in the terminal you can just give S2, it will print S2, is case sensitive, right? You will see that only 6 elements are present. And the next operation is intersection. We know already intersection means we'll try to find the common elements between the sets. Okay, so intersection, how it is defined is by using this ampersand operator. Union is defined by the OR operator, that is pipeline symbol, and intersection is defined by this ampersand symbol. So I say S1 and 1, 3, and already we have seen that S1 is 1, 2, 3, 4. Just to recollect, I have already written on this slide. S1 is 1, 2, 3, 4. So when I am going to find the intersection of 1, 2, 3, 4 and 1, 3, I will get 1, 3, right? And next is the difference operation, right? Set difference. So when I say S1 minus this one, what will happen is it will print all element in S1 which is not present in this set 1, 3, 4, right? So S1 is 1, 2, 3, 4. So minus 1, 3, 4 will print 2. Okay, we will get 2, and empty sets must be created with the built-in and printed the same way that we have already seen. So you can just check it on your terminal, these things. So you can also print S2 and see. Yeah, you get 1, 3. Similarly, when you try this, you will get 2. Okay, so we can see it works as expected. So next what we are going to see is, as already we have seen, the empty set will be given like this. Now we are going to find out what is S1 minus 1, 2, 3, 4. We have seen that S1 is 1, 2, 3, 4. So when I say like this, it should print empty braces, right? That is what is expected. Set empty parenthesis it will print, because we already know that, see here it is printing set empty parenthesis. It will not print curly braces because that is reserved for dictionaries. And apart from these operators like pipeline symbol, ampersand, Python has also provided more functions. Why it is required we will see. When you try to do a union between two sets, actually it works fine. See, I am taking this first set 1 2 3 union 3 4. When I make it, I will get a set of 4 elements 1 2 3 4 5. But when I am trying to do a union operation with the list, it is not possible. I cannot say 1 2 3 union symbol and then a list 3 comma 4. I will get an error. If I want to perform something like that, then I have to explicitly convert it into a set using this function, and then I have to make it. But when you look at another one way, there is more ways. One more way to do union, that is by defining the using the function union. So when I am going to use this union function, I can either pass a set to it like this, or I can pass a list also. When I pass a list, then automatically by implicit it converts the list to a set and then do the union. But whereas if I am going to use the operator or operator, that is a pipeline symbol, then I have to take care of converting that to a set and then only we can do it. That's the difference between these functions. These functions are like having more options when you compare to the operators whatever is defined, right? And next is difference. Already we have seen about it, that is difference is possible using the minus operator, but in addition, similar to union function, there is also a difference function. So you can take this set, okay, which is having 5 elements A to E, A, B, C, D, E, and then I have got Y which is having 2 elements B and C. Now I can find what is the difference between X and Y by using X dot difference of Y. You will see that Z is going to have the difference in the elements, right? So you can just check it in the terminal. And we can say Z is equal to X dot difference of Y. And now I can print Z. You will see that the order, as I told already, order is not going to be same because set is a unordered collection. Here you can just note that it is printing AED, right? Yeah. And there is one more function, difference update, which is similar to difference. What is the difference between the function difference and this difference updaters? Difference will find the difference in the two sets and will return another one set. But when you look at this difference update, what it will do is it will remove all the elements from another set and then it will update the set through which it is called. For example, if you have X as A, B, C, D, E and Y as B, C, when I say X dot difference update of Y, I am calling this function through the set X. Okay, so what will happen is it will find the difference and update the X through the object through which this function is called will be updated. So when you look at X after that, it will not return. This function will not return. Previous function when we were working with that, right? You can see the terminal. What we were doing, we were finding X dot difference of Y. It was returning a set. It will return a set in which the elements of X which is not present in Y will be given. But when you look at this difference update, this function will not return anything. Instead, it will change the set through which this function is called. We can just make it sure by just checking it on the terminal, right? Already it's there. So I can say like I can even say Z is equal to just confirm that it doesn't return anything. If I print Z, nothing is coming, right? Because Z will be none. It doesn't return anything. So Z will be none in this case. But if you print X and C, X will be modified. In the previous case, X will not be modified. That is, when we are using difference function, X will not be modified. Instead, a set will be returned with the elements in X and which is not present in Y. But when you look at here, the set X will be modified to have the elements which is present in X but not in Y. That is the difference. And next we have few more functions like is joint and then is subset. So is joint function, from the name itself you can understand, when we will say two sets to be disjoint is if they do not have a common element, or when you take intersection between the two sets, if it is null, then we will say that they are disjoint sets. So this disjoint function will return true if the two sets have a null intersection. And then is subset. Is subset, from the name itself we can conclude that it will return true if X is subset of Y. The usage will be like X is subset of Y. So if X is subset of Y, then it will return true and false otherwise. And equivalent to this subset, we have operators defined like less than or equal to or less than. So when you see less than or equal to, it is abbreviation for subset of, and greater than or equal to will be superset of. Okay. But when you look at this less than symbol, it will check proper subset. So what is meant by proper subset is, it is like it will not be equal. That is what is less than. Okay. When we say examples, you can just recall what you have learnt in your school, right? Similarly, is superset. Okay. Is superset of Y will check whether X is a superset of Y, and it will return true if it is so and false otherwise. So consider this set X with 5 elements A to E and Y with 2 elements C and D. If I check X is superset of Y, yes, the elements whichever is present in Y is also present in X, right? So it will return true. Okay. And greater than, we can use greater than, similar to less than. Greater than can be used for superset, right? But when you use greater than, it will check whether it is a proper superset. That's what we should just confirm. So just check this. Actually X is having 5 elements A to E and Y is having 2 elements C, D. When I check X greater than Y, true. Okay, because X is superset of Y. And this Y is actually a proper subset, so it will return true only. Similarly, I can say X greater than or equal to Y. Yes, true. That is also true, because when I say greater than or equal to, it includes the even when they are which is not in proper subset is when both the sets are equal, right? Then we can also check X greater than or equal to X, right? That is, I am checking whether X is superset or equal to X. It will return true because X is equal to X. Next, if I check X is greater than X, that is whether it is a proper subset, proper superset, proper subset, no. Okay, because they are equal, they are having the same elements, so it will return false. But when you check X is superset, this is the difference between these two. Actually, this is superset is equivalent to greater than or equal to, that we should understand. Okay, so when this function is used, X dot is superset of X, it will return true because it is going to return for all cases. It is not going to check whether it is a proper subset and proper superset. Similarly, subset, right? Is subset of Y, X is subset of Y? No, because X is having more elements when you compare to Y. Whereas if I call, see, this will be checked. Okay, this will be checked with respect to the other one. So when how should I read this is, I have to check Y is a subset of X. Y is a subset of X? Yes, because the elements present in Y are present in X also. And again, less than, we already seen that it can be used with for checking subset, and less than equal to will be more flexible when you compare to less than. Less than will check whether it's a proper subset. So once again you can see X less than Y will be false, but Y less than X will be true. Okay, because Y is a proper subset of X, and X less than X is false because it is not a, X is not a proper subset of X. But when I am going to use less than equal to, I will get true because it is equal, both are same. Next, few more functions defined for set or pop. Actually, pop will help to remove an element from the set, any element. We cannot ensure that this particular element only will come. Arbitrarily some element will be removed from the set, right? and the method, this pop method will return will raise a error, key error, if the set is empty, because it cannot pop anything. So when you try this, we can also try on the terminal and check this. So when you are going to try this, x is equal to this set, okay, and when I try to say x dot pop, say I am getting C. Actually they got A for the first time, but this time I am getting C and next A. So it depends on how it is going to be retrieved. So randomly some element will be removed. You can also check that it will be removed. You can just print x and C. It is having only the remaining elements. Okay, fine. So next, discard function. What is the use of discard function is, we can send a element. If I want to remove particular element from the set, then it is possible using this discard function. So I will be passing a element EL, that should be removed from the set. So when we pass it, that particular element will be removed. So consider the set from A to E, and when you call x dot discard of A will be removed from the set. You will be having only the rest of the 4 elements. If I try to discard Z, then actually Z is not present in the set. I will not get any error. It will just keep quiet, and the elements, all the elements will be present in it. And the next method is clear method. Clear method will remove all the elements from the set. So for example, if you have 3 city names like this, and when I say cities dot clear, it will remove all the elements from the set, and if I try to print, the object will be there, but clear function will only remove the elements from the object, but the object will be still existing. So if I try to print cities, I will say that it is printing a empty set. And then we have already discussed about this shallow copying and deep copying. The same thing is applicable for sets also. So when you look at the assignment operator, it will only create a shallow copy. So let me show example. This is one set, more cities with 3 city names, and I am using the assignment operator and creating another one variable, cities backup. When I am going to use like this, actually it will be a shallow copying, and it will be only like a alias name. Same object will be having 2 names, that's all. More cities as well as cities backup will be referring to the same memory when we do like this. And when I try to say more cities dot clear, I am removing all the elements from more cities, and when I try to print cities dot backup, I will find that empty, because both of them were pointing to the same object only, same memory only. Since we have removed using one of its name, even when I print through the other name, I will see that it is empty. So how to do deep copy is, already we have seen this for list. The same way, there is a copy function defined. We can use the same copy function here also. So let's consider the same example. When you have a set, more cities, and when you want to create another one set, okay, with deep copying, then you have to use the copy method, more cities dot copy, right? And then you verify whether it is correctly done. You clear the more cities, and when you try to print the backup cities, that particular cities backup set, you will find that it is present, because they are different memory. When you do a deep copy, the memory will be separately allocated, and then the contents will be copied from the original set into the new set. Okay. So when we started about the set, we were saying 3 important properties of set. First thing is, it is an unordered collection. Second one is, it is going to have unique elements, there won't be duplicates. And the third thing is, the elements of the set can only be immutable, right? So again we are going to see how it is being stressed. So we know that list is mutable, dictionary is mutable, and tuple is immutable. So I am going to see whether it is possible to add a tuple. Yes, first thing is, we are trying to add a list. When we put within square brackets, you know that you are trying to add a list. You will get the error like this. You can just see it on the terminal, so that you will get a better feel. 1.23. Fine. Now I am trying to add oh sorry, 1 minute. This is case sensitive, so this is the issue due to the case sensitive thing. Now you can see the error that is getting printed is saying that unhashable type list, because it is mutable. Immutable things are only hashable. Okay, so you are getting this error. Next, I am trying to add a dictionary. If I try to add a dictionary, what will happen is again I will get an error, unhashable data type, okay. And when I try to add a tuple, okay, when I put within parenthesis, it's a tuple. So when I try to add this, I will see that it is getting added to the habit. I am keeping a dot. Okay, so when you see that now S is having two elements. When you look at the len, you can use the len function for the set also. You will see there are two elements only. Okay, this is the first element which is a float. This is the second element which is a tuple. Okay, and then when you look at the union operation, it can be performed, right? I can just say like this. So let me try this. Now I am going to take union. The second one is a dictionary with two elements. Okay, second one is a dictionary with two elements. Can you see here? The first element is a tuple with 4, 5, 6, and the second one is the tuple with elements 1, 2, 3. So when I take union with this, already I had two elements in S, 1.23 and a tuple 1, 2, 3. Now this 1, 2, 3 will not be added again. Only 4, 5, 6 will be added, because just recollect, sets are unique elements, set of unique elements, right? And I can use the in operator. So you can check whether it is present in yes, true, okay, because it is present. Order is very, very important, right? I can try out this. What I am going to do is the same elements I am going to say 2, 1, 3 in S. Okay, if it is present in S, no, because 1, 2, 3 is only present. The order of the element, when you consider tuple, it is an ordered collection. So order is very, very important. So it will say yes, only, true only if the same order is given. This is different from that. Fine. And next what we are going to discuss is about frozen sets, right? So we have seen that you cannot add a mutable object into a set. So what about set? If I want to add a set into a set, whether it is possible? It is not actually possible as such, because sets are mutable. You have to understand that point. Sets by themselves are mutable, but the elements can only be immutable, right? So how can I add a set into a set? Is for that we have to build something called as frozen sets, right? So how you can build a frozen set is, there is a function, built-in function present, frozen set of, then you can give a list of elements. It will build a frozen set. Frozen set cannot be modified. You can see in the next line, when we try to add a element into the frozen set, you will get an error. Let us check this on the terminal. So by using the frozen set function, I have created a frozen set. Now I am trying to add something into the frozen set. I will get an error, okay, because you can clearly see that frozen set has no attribute add. You cannot add into a frozen set, right? So you can use frozen set concept, and I can add into a set. Right now what I can do is, I have created a cities, isn't it? Now I can try to add this to S, right? See, S is here, S is having two elements now. If I suppose try to add, okay, try to add a set. I will get an error. I am not trying to add a set into a set. You can see that it is giving error, unhashable type set. But if I try to add the frozen set, it will allow me. So S dot add, now we created a cities frozen set. right. So it is allowing me. So if I print SC, you will see that 1.23, then you have got a frozen set into it, and then 123, right. Okay. And next what we are going to discuss is about set comprehensions. Already we have seen about list comprehensions and how they are useful for building a tuple and so on. Similarly, a set can also be built using the comprehension, right. So already if I have got a list or if I have got a string, then I can build a set using it by using this comprehension concept. So look at here, already there is a list. Assume that you have got a list with 4 elements 1, 2, 3, 4. I am going to square those elements and I am going to form a set, and I will get a set with 4 elements 1, 4, 9, 16, but not in order. Already we have discussed it's unordered collection. Similarly, from a string also I can just build it, right. So for x and spam I am just adding the elements, it's possible. And when I try, I can also do like this. This star operator we have already seen. For strings it is defined for multiple concatenation, and when I am trying to say like for C in spam, the characters 1 by 1 will come into C, and when I am trying to multiply by 4, it will be concatenated 4 times. So you will see that all the 4 characters are concatenated 4 times, and now it will be present in the set S. And now if I am trying to add spam ham, right, if I am again adding like spam ham, what will happen is in this spam ham you will see that A, M are getting repeated, isn't it. So they will not come again because sets will not have duplicates, right. So if I give C star 4 for C in spam ham, I will have only totally 5 elements because A and M are repeated, so it will not come into the set again. So when you want a group of elements without duplicates, you can go for set. Even you need not explicitly check by using the in operator or anything when when we are going to add it to a list. Instead, if you just add it even, it will not put it to the set due to the property. And also I can try adding like this. I can do this is union, this is intersection. Again, if it is a duplicate, then it will not be added. Now we started with the problem, that is we are having 4 list of failures in different subjects like maths, physics, chemistry and computer science, and you want to find the total number of failures. Now when we look at the code, actually we are going to have 4 sets, okay. Set max we are initializing by empty sets, right, and then you are getting a input, right, for the number of elements in the max failure, and you are taking the input one by one and you are putting into the math. This is another way. One way is you can just say add of val, that is one way. Math dot add of val will also work, but this is other way. I can just create a singleton set. Singleton set means set with one element. So when I put curly braces and put that val inside, then I am going to have a singleton set. I can concatenate that with math, that is also possible. And then you are creating another one like physics and then chemistry, right, and we can also similarly create for CS, right, and then I can just use this operator, right. I can use the union operator for putting everything together. When we put everything together, I will have only the list of failures in the examination, and after that I can use the len function. Now only we used on the terminal. Len function will say how many elements are there. So I can use the len function and find out the total number of failures. Okay. So sets are very easy to use for problem solving. You can explore more by solving the problems. Thank you.